All right. Hi. So we're just going to start soon. Today I'm going to be doing a little. 1 second. Give me 1 sec. Yeah, today we're going to be doing Alcumus and we're going to. Okay, so we'll start off by just seeing how the Alcumus is going so far and what areas I need to continue working on. And then we'll go and work on those areas and see. I'm going to try to. Now, I know the stream title might say something like um solving problems until one beats me. There'll probably be a lot more than one that beats me. Because I'm not doing the easy stuff. I've already probably finished a lot of that. So I'll probably take breaks throughout as well, depending on how long this takes. But I don't aim to take too long. I don't have that much time right now free. And maybe an hour or two of just solving questions. And I think it's time I share my screen. So here we are. This is where I'm at right now. Pre-algebra obviously is not really interesting. I'm not going to be spending any time doing that. Doesn't make sense to do that. Same thing with algebra. Number theory, counting and probability, and geometry, I've already done most of them. In geometry, there's like one bar that's still green, which I haven't finished yet, but I'm not going to chase that. Instead, let's do some intermediate algebra and then just see how that goes. We most probably won't be able to finish it or do a whole lot of it. But if we are able to, then the next target will be pre-calculus. We might also flip-flop between them if need be. But right now, the idea is just to do intermediate algebra. So let's do that. How do you, oh, okay, play. All right. Well, we're already in basic rational functions, equations, and function equations and inequalities. Okay, and so we're asked to find all real numbers x such that, and then we've been given this inequality. Okay, so the way I'm going to do this is I'm going to screenshot all the questions and then I'm going to put them onto this whiteboard over here, which you should be able to see. And then, 1 second. Yeah, okay, and then we're going to solve it over here and submit our answer. And you guys, of course, can engage with me in the chat. You can just like share your own thoughts. If I'm stuck somewhere, if you want to help out, you can do that. If you think I'm doing something wrong, you can do that. And obviously, if you have questions, you can ask those as well. Right? All of that's you can do anything you want, right? So okay, so this is the sort of thing where you have to be a little careful about sign, I believe. But okay, so usually what I've been taught to do is, or whatever I learned in school, um, is to essentially just do 3 minus x over 2x minus 5 is less than or equal to 0. And then you do the same thing on this side with this equality over here, and then you solve it like that. That's not really the best approach, I think. And instead, if you just break it into two cases with x is 5 over 2 and x is less than 5 over 2, if we just consider cases and solve them, we should probably be able to get a slightly nicer and faster answer. So this is what we're going to use here. I'm just going to rewrite it over here very quickly. So 3 is less than or equal to x over 2x minus 5, which is less than 8. So the first case where x is greater than 5 over 2. If that's the case, the denominator is going to be positive, and of course the numerator will also be positive. So that means that we can multiply by 2x minus 5. So when we do that, what do we get? We get, and we still do have to break it up into two different things. So let's do that. We get 6x minus 15 is less than or equal to x. And from here, we get 5x is less than or equal to 15. Yeah, and so x is less than or equal to 3. Does this work? Well, what are we considering? This is the case with x is greater than 5 halves. So this is the case if x is greater than 5 halves and x is less than or equal to 3. We know that that's going to just give us 5 halves until 3. Now we also have to consider this case over here though, right? So let's see that. We get x is less than 16x minus 40. And this just becomes 40 is less than 15x. Hello, Yash. Okay, I think that looks about right. So we can divide it now and we get 8 thirds is less than x, right? You just divide by 5. Okay, so x is greater than 8/3, and does this work with this constraint? Yes, it. So, well, which one is bigger? 8/3 is bigger. So yeah, so then we just have 8/3 until infinity. This also works. Wait a second. This doesn't really make sense, though, because if we've 3 is more than 8/3, so that shouldn't really work. Maybe there's a mistake somewhere here. This is really not a hard question to waste so much time on. It's a pretty easy thing. So, all right, let's see. 6x minus 15 is less than 8x. 6x minus 15. Okay, I mean, this should be fine. I don't know if there's something wrong with this approach. It seems fine to me. X is greater than 5 halves. So 2x is greater than 5. 5 minus 5 is 0. 6x minus 15 is less than or equal to x, correct? Well, it might just actually make sense then. Because if you're more than 3, like, what will 3 give you? That'll give you 3 over 1, which is fine. And then 4 will give you 4 over 3, which is... Oh, no, sorry. It needs to have both of them, right? It's the union of both. Okay. So x is less than 3 and x is greater than 8/3. So we want 8/3 is less than x is less than or equal to 3. And this works because 8/3 is a little bit more than 5 halves. So this part works. All right, done. Sorry, I messed up. It's not the union, it's the intersection. Okay, now we consider the next case with x is less than a little neater. Um, x is less than 5 halves this time, and we've got the same thing. What is that? That's 3 is less than or equal to... Okay. Now when we do it, we have to be a little bit more careful because this is going to be negative, so we have to flip the inequality. So that gives us 6x minus 15 is greater than or equal to x, and we get x is greater... Oh, this is the exact same thing, obviously. 16x minus 40. So we'll get the same answers, but they'll be same answers, but we go on the other side, right? And so to do that, we're going to get... Give me 1 second. All right. Yeah, let's proceed. So we have 5x. Okay, same thing. X is greater than or equal to 3. This so we have x is less than 8/3. There's probably nothing over there. Is there? X is greater than or equal to 3 and x is less than 8/3. Yeah, there shouldn't be anything there. Well, the only way this would work is if what would a negative value give you? Like negative 3, for example, would give you negative 3 divided by negative 11, which doesn't work. Okay. Yeah, I guess there's nothing here then. But this seems off to me for some reason. I don't think this is right. Okay, well, let's just see. 8/3 is less than x is less than that. So it's from 8/3 until 3. Oh, okay, that is it. And what they did was this original technique. You know, this might actually be faster. I'll give it credit. Subtracting 2 also works. That's probably smarter. Yeah, that's smarter. Okay. All right, fine. Well, done with that. Now this one, the magnitude of x squared minus 81 over x squared minus 36x. So if we want this to be less than 0, the absolute value, the absolute value is obviously going to be positive or 0. The only points where it'll be 0 is when when x is 9 or negative 9. X squared minus 36x then has to be 0, and that's going to happen. That's just x times x minus 36. So the only times that that's going to be 0, uh, the only time that that will happen is when x is between them, so between 0 and 36. So that would mean 0 to, and 0 obviously can't be included because I would give a division by 0 error. So 0 until 9, and then I want the union. So how do you put the union? Oh, just u. Okay, and then from 9 until 36, but again 36 can't be included. And then that should be all, because any time you have another value, any time you have another value outside of the 0 to 36 range, you're going to have a positive denominator as well, and then it'll never be less than 0, right? So that's what we want. Okay, solve this. Well, I think just if you cross multiply it, there will be some patterns, because you'll get x squared plus 10x, x squared plus 10x divided by something, plus 9 plus something else. So yeah, we can do this and then do a substitution, I believe. But it should be pretty easy. Let's see. We'll expand it and see. I'm pretty sure this is fairly simple. So let's try it out. Yeah, or actually, the smart thing to do might just be to, yeah, the easiest thing to do is probably just write this as x plus 2 minus 1. So this is 2 minus 1 over x plus 2 minus 1 over x plus 9 is equal to 2 minus 1 over x plus 3 minus 1 over x plus 8. And so cancel out. So we get 1 over x plus 2 plus 1 over x plus 9 is equal to 1 over x plus 3 plus 1 over x plus 8. And now it's not too difficult over here. If we cross multiply, we'll get 2x plus 11 over here. And over here, we'll also get 2x plus 11 in the numerator. And then the denominator is x plus 3 times x plus 8. And over here, it's x plus 2 times x plus 9. Oh, 1 second. I'm getting some. All right, great. Yeah, now we want to set these equal. So either x is negative 5 over 11, and that'll make it 0 equals 0, or we have something else. But sorry, negative 11 over 2. That's negative, I don't know why I said negative 5. That's negative 5.5. Um, wait a second though. Yeah, and I'm pretty sure that'll be the same as whatever you get if you actually expand these, right? So the alternative is just to cancel these out and and then c. So, okay, either negative 11 over 2, that's one option. But if you just expand these, you'll get x squared plus 11x plus, oh, okay, plus 18, and over here, x squared plus 11x plus 24. And these will never be equal. So the denominator just cannot be equal. And so for that reason, it has to be negative 11 over 2. I'm pretty sure that's right. Okay, one more. Solve this. Okay, I'm gonna just screenshot it in, and then after to do this, it's not too bad. I think we can just make a little table of the key values to consider, which will be 1, 2, and negative 7, and then just look and see where it'll happen, right? So let's say we're going from, this is negative infinity, this is negative 7, and then from that we need to go over to 1, right? And then 2, and then back up to infinity, and now we just see what happens, right? So when you have negative infinity, it's going to be negative infinity, negative infinity, negative infinity, which is negative infinity. When you have all of them, going towards positive infinity, that's going to be positive. When it's, oh, sorry, what did I do? I should be, oops. Yeah, no, I should be considering the intervals, not the numbers. That's a pretty stupid thing to do. All right, let's do it like this. Okay, negative 7 to 1, to 2, and 2 to infinity. All right, same exact thing, just a little nicer to look at, I think, and fewer lines as well. This is not 8. Okay, this is negative infinity. So yeah, this is the same thing, negative infinity, it'll all be negative. Here it'll all be positive. Yeah, and when you're going from 1 to 2, you're going to have a positive times negative divided by a positive, so that's a negative. We only care about the sign, this really doesn't matter. And negative 7 to 1, this is going to be positive, but this is going to be negative, this is going to be negative, that's going to be positive. So it's just this and this. So negative infinity to negative 7, the union of that with 1 to 2. And you cannot ever have the actual points in as well. Okay, U for union. Negative infinity to negative 7 union with 1 to 2. Yeah, that seems right to me. Wait, what's wrong? Something wrong with this? Maybe I need spaces here. Okay, I mean the formatting seems wrong because it's in red. Okay, it's fine. For which values of k does the equation have no solution for x? So I mean they're probably okay, I think we can just cross multiply. It's -1, -2, minus k, minus 6. So it's like this, it's x minus 1 over x minus 2 is equal to x minus k over x minus 6. So we cross multiply, we get x squared minus 6x minus x plus 6 is equal to x squared minus 2x minus kx plus 2k. And if we want no solutions to be there, obviously the x squareds will cancel out. To make sure that we have negative 7x on this side, which we do, we want this to also be negative 7x, so k equals 5. And I think that's it. Right, I don't think there's anything else, because then you'll have 10 and 6 being equal, which is not, so it should just be 5. I don't think there's any other value, but they are saying it's a list of answers, so let's use that. Oh, okay, I mean, I guess if 6 is an answer to this, that also should not work, right? So 2 and 6 cannot be answers to this at all, right? So let's remove this, so 5 is one answer. We also want to just check that the answers that we get if we solve this, we should not have anywhere 2 and 6 as answers, because those are not right. So let's just do that then. We have 2k over here. What do we have over here? We have negative 7x. So let's over to the other side, right? We have 6 minus 2k is equal, that'll be 7x minus 2x minus kx. So that is 5 minus kx. And now if we equate these, well, okay, x. Yeah, okay. Now we plug in x equals 2 because this does not work, and x equals 6, which does not work. Right, 2 and 6. Yes, that'll give you 30 minus 6k. And this gives you ultimately, oh, okay, yeah, obviously 6 also won't work, right? Because 6 is just 1. X minus 1 over x minus 2 can never be 1. And then there's similarly, I think 7 should also work. Okay, I'm not sure about that one, but let's try. Okay, so this is just going to give us, this gives us k equals 6, and this gives us 6 minus 2k equals 10 minus 2k, and this does not work either. This will just never be true, so it should, maybe it's just 6 then. So 5 and 6, I think that's it. All right, okay, done. Let's continue. What's okay, done with that one. Now we're on advanced rational function equations and inequalities. So same thing as the last one, except it's a little bit harder this time. Find the largest. Okay, I've seen something like this before, and anyway, it's the same idea as one of the other ones we had. We did something very similar to this already, and it'll probably ring a bell when I actually start solving it. So let's do that. Here we go. Notice the symmetry with 5 and 17, 3 and 19. And so all we have to really do is take this one and put them together, and then these two and put them. So what we'll end up getting is 3x minus 57 minus 57 again. So 3x and 19x. So 22x minus 114 over x squared minus 22x plus 57. And now we're going to get something similar over here. We're going to get, sorry, 22x minus 85 times 2. What is 85 times 2? 170. 170 over here. Denominator is x squared minus 22x plus 85. Yeah, these two. All right, and now we just equate this to whatever the thing on the right is. Wait a sec. Oh. No, actually, this seems a little harder. I don't really know. This is equal to x squared minus 11x minus 4. And so, I mean, I was thinking about making a substitution here and calling, say, x squared minus 22x plus whatever is halfway between these, making that into one of the values, but that doesn't really make too much sense, I'm thinking now. So maybe we can do 11x minus 2 as something. Nah, that doesn't really help either. Okay, wait. Does x squared minus 11x minus 4 factor nicely? Not at all. It's pretty ugly. So we can't really use that either. What could be going on here? Well, it doesn't really help to just have the 22 and 114 just lying there like that. So either we can add a plus x squared, or well, add a plus x squared and subtract x squared, and then we get something that vaguely resembles this, or we can let's try that. Let's just try that and see. So we have x squared minus x squared plus 22x minus 114 over x squared minus 22x plus 57. Of course, the reason doing this is that this can now be written as -1, and then I believe it's okay. This is what, and this doesn't help us. It maybe makes the book even harder, right? Because it's, what has it done for us? Nothing. So yeah, this might not be the way to go. Okay, wait. So what's the strategy over here? If there was subtraction going on, I think that would make it nicer for us, but that's not the case, unfortunately. So okay, fine. Let's let, yeah, okay, this is a little bit, if, oh, let me check the chat if anyone's got any ideas to share. Yeah, okay, no one else is there. So let's see. It shouldn't be that hard. Come on, let's just try to brute force it and see if we get anything. So 22x minus 114 over x squared minus 22x plus 57 plus 22x minus 170 over x squared minus 22x plus 85. And so now we can, I guess, I don't want to, but we're going to get some very ugly numbers, so that's why I don't really see. Okay, let's look at the question. There are positive integers a, b, and c such that this is the case. I mean, is it such a bad thing to expand? Okay, you don't know. We're not going to expand. That's very stupid. But maybe we can do. So my other thought was that this is x minus 11 squared minus thing. And then this is x times x minus 11. So we can say that's y plus 11 times y. Right? And then this is, what is that something? It's like 40 for 54. Yeah, 54. But this also isn't particularly helpful. It's actually probably bad for us to do. So maybe then the solution is just to do x squared minus 2x equals something. But then in that, I'm worried about what happens to 22x over here and this over here, which don't really match the same form. Right, so that's my worry over there. Now we can divide by 2, or yeah, so we can take out a factor of 2 and get 11x um minus 57 plus 11x minus 85, and it looks nice. It doesn't look lots of repetition over here, but what I don't know is how this really helps us, because the same substitution still seems challenging to make. And of course, because we divided by 2, we need to account for it somewhere, so we lose here. But now actually solving this still doesn't seem nice at all. It's still very ugly, I think. And so if you have any thoughts, just put them in the live chat and I'll see, because I'm a little unsure of how to proceed over here. This is the question. So we're just going to find the largest solution to this. And all right, now we don't have to necessarily continue with this for now. So we'll keep this saved over here. It's not going to go anywhere. But just to make some progress, let's look at advanced complex numbers for a sec. Okay, yeah, this looks pretty bad, but probably not that bad. Okay, so we're looking for the real solutions to this and then doing it. We'll keep looking around until we find a nice, tractable, easy sort of question, solve some of that, and then we can continue from there. So let's go to the inequalities place. Okay, so that's a little bit ahead over here. General inequalities skills. Now, the only way that this won't be the case, the only way that this will happen is if b equals a and well, I mean, so let me. They're all between 1 and 100 inclusive. So I think it should. I think the immediate answer is just a equals b equals c, and then these belong to 1 to 100. So there'll be 100 of these. That's my initial instinct. But now let's actually try to figure it out, right? A squared plus b squared plus c squared. Write this as we can do this times 1 squared plus 1 squared plus 1 squared. And by Cauchy's, this becomes just a plus b plus c whole squared. And so this is 3 times a squared plus b squared plus c squared is greater than or equal to this is greater than or equal to a squared plus b squared plus c squared plus 2 times ab plus bc plus ac. And of course we can cancel out a little bit, and now we'll end up getting just a squared plus, yeah, so we just subtract one of these from both sides and we divide by 2. This is an a, not a 9, and this is greater than ab plus bc plus ac. Now the important part over here is that we use Cauchy-Schwarz to come up with this inequality, and that means that a over b equals, no sorry, a over equals b over 1 equals c over 1, which means a equals b equals c. And so yeah, that makes sense now. I don't think there are any hidden answers anywhere. You can also use the rearrangement theorem for this, I think, but in the end, you should have just 1 1 1 2 2 2 3 3 3 4 4 4 and 100 of them. All right, yeah. Okay, I don't know why they do this with the KKK. That probably was a better choice of variable there, but that's fine. Okay, now let's look at this one. The sum of the following 7 numbers is exactly 19. This. Each AI is, okay, is approximated by some integer capital A sub I for 1 is less than or equal to 7, such that the sum of the AIs is also 19. Let M be the maximum of the 7 errors. What is the smallest possible value of M? Okay. So to get 19 from 7, how many 2's do you need and how many 3's do you need, if those are your only options? No need to even do the math. I think it's, wait, it's 7 and we want 19. So it'll be like 2 times 3 plus 5 times 3. No, sorry, what am I doing? 2 times 3 plus 5 times, no, 2 times 2 plus 5 times 3. That'll give you 19, right? Yeah. So there are two twos and there are 5 threes. That's the only way it'll happen when we're approximating them. And yeah, we don't want to go out of this. We don't want to pick or something because m is a maximum of the 7 errors, and that error is going to become huge then. So we definitely do not want that. Now, which ones should we take that are next to 3? Um, which one should we take? Which of these numbers should we pick to round to 3, and which one should we pick to round to 2? Well, obviously, you don't want it to be, you want to take something that's bigger than 2.5 and round it down to 2, or something smaller than 2.5 and round it to 3. Actually, we kind of have to. Okay, so then we'll have to just do the smallest one's going to 2 and the biggest one's going to 3. Right? Like, I don't see what else would. Yeah, and it doesn't really make sense to do anything besides a 2 or a 3 because then the difference would be much too large. So, okay, I mean, then it should be 0 point. They're in ascending order for us. Okay, great. I think it's just 0.44. Oh, no, no, sorry, 0.61. 0.61. Okay, it's not a, because you'll take the smallest two and round them down to a 2, and you'll take the other 5 and round them up to a 3. When you round them up to a 3, the differences you have are 0.14, 0.18, 0.21, 0.29, and then 0.35. But over here it's 0.39, sorry, 0.61 and 0.56, and the biggest one is 0.61. So that has to be correct. Yeah, okay, I thought there's some inequality behind this, but there really wasn't. Okay, the real numbers x, y, z satisfy this. So x is less than y is less than z, and then equalities are allowed. If their squares form an arithmetic progression with common difference to the squares form, okay, determine the minimum possible value of x minus y plus y minus z. So first of all, we know that they're all positive. So x squared plus 2 equals y squared, y squared plus 2 equals z squared, and I think that's it, right? There's nothing else there. Yeah, okay. Determine the minimum possible value of x minus y plus y minus z. So x minus y is going to be negative, y minus z is also going to be negative because we know that x is strictly less than y and y is strictly less than z. So this is the same thing as z minus y plus y minus x, right? Z minus y and y minus x, and right, yeah, and this is just z minus x. Now we know that z squared is equal to x squared plus 4, so z minus x times z plus x equals 4. Z plus x equals 4. Okay, yeah, we know that. Oh, okay, 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 I think it's just okay. We know that. So what can we say about z plus x? Well, whatever x is, z has to be at least, okay, wait, this is, if we take x is equal to 0, then squared plus 2, so then y is going to be equal to root 2, and then z is equal to 2. So then that would allow us to have x minus z as well. Because we want to, if we want to maximize this, we want to minimize this because we're going to divide by that. And so to minimize that, I think we just look at it and see what's possible. Because the squares form an arithmetic progression with common difference too. Yeah, 0 squared is 0, root 2 squared is 2, 2 squared is 4. That should be completely fine. I don't know why that wouldn't work. And if that's the case, yeah, then the maximum value of z minus x. It'll be 2. Let's see. Oh, it's a square root though. I think we're fine in saying this though, because this is still positive and this is still positive. So we're right, it's 2 minus root 2 plus root 2 minus 0, which is 2. Can it be anything else? I don't think so. I don't think so because see, x plus z is always going to be greater than z plus x is always going to be greater than z minus x, or they can be equal, but they're only going to be equal when x is equal to 0. And we know that that case does work. If it didn't work for whatever reason, I'm not trying to rush Subhakanta, but I'm trying to just move on from this question because it's doesn't seem that bad. And I want to move on to the other inequalities as well after this. So the minimum possible value, it'll be y minus x plus z minus y, which is z minus x. So that's all we need to find. And so x squared plus 2 is y squared plus 2 is this. So this statement is also correct. We can say x squared plus 4 equals z squared, from which we know that z squared minus x squared is 4. So if this is the case, since z minus x is greater than 0, z plus x is greater than 0, there's no negative and negative. I mean, okay, that doesn't even matter. But we know that z minus x is less than or equal to z plus x. Equality only happens when x is equal to 0. So I think x equals 0 should be just fine. Now, if this were some arithmetic progression of common difference to the real numbers, 0 is real, root 2 is real, 2 is real. The only reason I'm not happy about this is because of the formatting tips with the square roots. But I don't think we need a square root over here. Right? Like it doesn't seem necessary to me. I think it's just 2, so I want to put it in and see. Okay, it's wrong. I don't know what's wrong with this though, right? Because the logic seems fine. The real numbers x, y, z, x is less than y is less than z. The squares from an arithmetic progression with common difference 2. Yeah, so it'll be x squared plus 2 equals y squared. Y squared plus 2 is equal to z squared. And then if you just add these equations up, you'll see that x squared plus 4 is equal to z squared. If anyone sees the mistake here, just let me know, because I don't. This looks fine to me. The only thing that could be an issue is, I mean, really, I can't find anything that would be wrong here. Okay. If you can think of anything, just put it in the chat, because I don't want to get the question wrong. We've only got one more try, and the first thing didn't work. So Common difference of 2, determine the minimum possible value of this. Oh, it's minimum. Wait, okay, that's very stupid. Okay, wait, one sec. I misread. I thought it's maximum. That's what I messed up. If we want minimum, the same logic here should hold, but now we want to maximize z plus x. And the best way to do that is to have, so yeah, we want to maximize z plus x given the fact that z squared is equal to x squared plus 4. So z is at least 2. Um, y can be anything in the middle. That y is pretty insignificant over here, I think. No, not for AIME. This is just for fun now. I already did AIME last year and the year before, so it should be. Hopefully, I'll get it again, but I have college apps anyway, so. Oh, okay, yeah, that's good to hear. Are you grinding for AIME yourself, Tim? There's a slight lag between what I'm saying and the messages, but okay, yeah, good luck for that then. I make lots of videos with competition questions, so like a lot of stuff from AMC 12, AIME, Stanford Math Tournament, and that sort of stuff. So they're not really organized by different topics, but if they're helpful, you can just watch them. Yeah. For number theory, I recommend the AoPS book. It's pretty good, and then after that, you can just do a lot of practice questions, and you should be good with that. Yeah. Thank you, Tim. Okay, let's see this though. Um, okay, wait. I don't know what's taking so long. If the squares from an arithmetic progression with common difference 2, determine the minimum possible value. So then, oh, okay, wait. Then why won't we just take z, same logic as before, but now we just do it this way. Z equals 4, which means z squared is equal to 16. So x squared is equal to 12. And if this is the case, what is this works, right? Yeah. So this is equal to 4, and this is equal to, I think, 2 root 3. And then y squared will be 14, so y is root 14, but that doesn't really matter. So we've got 4 plus 2 root 3 times the difference. Okay, yeah. Volume 1 is good, and then it's got lots of practice questions. That's what I like about it. And then once you finish that, if you volume 2, I personally feel it's a pretty big jump because it gets a lot more difficult, but that also has some good number theory stuff in it, if you're interested in that. Level 25 problems are similar to high AMC problems or low level AME. Level 25 on Alchemist over here. Oh, okay, yeah, that makes sense. Level 23. Okay. Yeah, I don't really use Alchemist. It's actually my first time doing this in quite a while. So yeah, okay. But I mean that's good to know that I never really looked at the levels. So yeah, this will just be 1 because it's 2 times 2 plus root 3, 2 minus root 3. So that's 4 minus 2 root 3. Now that makes more sense because they said that there's a square root involved. Okay, don't mess up the typing. 4 minus 2 root 3, 4 minus 2 root 3. And that looks about right to me. Okay, let's submit. All right, good. Let's do one more. Suppose f of x is a function and it's invertible, and then okay, so we want to find the graphs of y equals f of x squared and x to the fourth, and how many points they intersect at. Okay, I think I mean I okay, wait, so it's defined for all real x. So obviously at x equals -1, 0 and 1, it'll be the same thing. It'll be f of 1, f of 0, f of 1. I don't think there are any other values. Yeah, there aren't any other values like that. So my first thought is just 3. Now there might be other points as well though, but I mean those other points would have to be very arbitrary, right? Like how do you pick another point? There's nothing special about them. It's just you just set x squared equal to x to the fourth. So I think it's just -1, 0, 1, and that's it. Now I don't know why this invertibility thing is. Oh, okay. Oh wait, no, one sec. Suppose f is invertible. Then that means that okay, no, it should still be fine. So I think it'll be 3 if it's defined for all real x. The graphs of this and this. So like I'm thinking something like a cubic maybe. But then if you do x squared, no, I'm old now, Tim. I have my college apps coming up. I'm a rising senior. So I think it should just be 3. Yeah, okay. Find the smallest positive real number. See such that for all non-negative real numbers x and y, this is the case. Okay. Um, I think we can probably just square this and see what happens. Let me screenshot it in though. Well, okay, we should probably keep the radical on its own side, right? So let's bring these over here. And then square. So we'll have c squared x plus y squared minus 2xy. Because the magnitude squared is just, I think it's just this. Plus squared plus y squared plus 2xy over 2. And then there'll be what? There'll be minus c times x minus y times x plus y. Did they all non-negative real numbers x and y? Okay, wait, no, I mean, I think that there should probably just be a better way to do this rather than actually expanding everything. So let's try to think it through. Um, yeah, that definitely has to be a better way. Okay, well, first of all, we can simplify this a little bit just by, instead of the absolute value, because it's all symmetric, it's x, y, x plus y, and x absolute value of x minus y, we can just say that let x be greater than or equal to y, and then this will simplify our stuff a little bit. Now we just have mostly the same thing, but now this will be, instead of absolute value of x minus y, we can just say x minus y, and it doesn't really help us all that much, but yeah, now we get rid of this, the lines. Now it's a little simpler. I still don't think we need all of this necessarily, but let's keep it anyway. This is xy. Okay, now we can simplify it a little bit. So we have c squared times x squared plus y squared minus 2xy. And then over here we have plus x squared plus y squared over 2. We have plus xy, and we have another plus xy over here. So we don't need that. And then we have minus c, and then this is x squared minus y squared is greater than or equal to 0. I think that's it. We've simplified the whole thing now. And now there are a few more cancellations that we can do. So we have c squared x squared. Well, okay, wait, is that c squared or? Yeah, that'll be c squared. Okay. C squared x squared plus y squared is 2c squared xy. Here we have x squared plus y squared over 2. And then minus c times x squared minus y squared is greater than or equal to 0. So if we want this to be true, we can just bring these terms onto the other side, I guess, but it doesn't really look nice. Yeah, okay, this is a little ugly. Let's see. There should be a nice way to do this. Yeah, it's still a little ugly. We can use AMG. Wait a second. If we use, we know that x plus y over 2 is strictly greater than or equal to the, not strictly obviously, but yeah, greater than or equal to the square root of x y from the AMGM inequality. So if we bring this onto the other side and we just look at this a little bit, and remember this is still with x is greater than or equal to y, that's our condition here. If this is the case, we can maybe do something similar, and yeah, okay, we won't get the, hmm, we won't really get a nice expression then. I think let's just stick with this and see. We know that, well, this is also very ugly to work with, and I really don't know what to even do with this, to be honest. Find the smallest positive real number c such that for all non-negative real numbers x and y. Maybe instead of writing it out like this, we can just write c times the absolute value of x minus y is greater than or equal to x plus y over 2 minus the square root of xy. Right, and we know that, what is this? What is x plus y over 2 squared minus 2 minus the square root of xy? This is probably easier because it gives us a clean expression with c. It's not too ugly. So that's x squared plus y squared minus 2xy. And over here we're going to get um, x squared plus y squared over 2 plus y plus xy minus, the square should be here. The square should be around the whole thing. That's what we did over to get here. And we ultimately end up with oh, so this is a little unsightly still. Greater than or equal to. Okay, yeah, I'm not really sure. This doesn't even require the other things. It's just a general inequality. So what could be wrong with our logic over here? Maybe you can just look at some possible values. So if we say x and y are both 1, just to get a sense of it and see what would happen. If x and y are 1, we're already done. C can be anything, C literally anything. But if we take, for example, x is 2 and y is 0. Okay, yeah. If x or y we take as 0, then we need to prove that. So let's say x is 0. It's not the right way to do it, I think, but I mean, probably not the right way, but then this is just going to be 0, right? Because it's 0 times y plus c times x minus y, the magnitude of the absolute value is going to be c times y. And we want this to be greater than or equal to y over 2. Yeah, I mean, I think it should just be 1/2 then, right? Obviously, this is not the best way to show it, but I think this is like a fast enough way to guess an answer, and then we can check the answer. And I think if we check the answer, it'll turn out to be right because I'm pretty sure minus 1/2, well, okay, minus x minus y over 2. This is just 2y over 2, and then that's just y is less than or equal to x, y. We said that x is greater than y, right? Or did we say it the other way? Okay, let's read that. So why don't you take a geometrical approach? Imagine taking x plus y over 2 equals mean, okay, x minus y equals 2d, and xy equals that. Just ideating, don't take it seriously. Um, it's not a bad idea, but I think we're close enough just with the algebra, so maybe we can stick with that for now. But I think that maybe you can just try that yourself, like draw it out and see what happens. But that's probably a good idea. I was also thinking there's a geometric meaning earlier, but I didn't really end up coming up with one. But that's a good idea, Subhakanta. Okay, but yeah, this is a little annoying. If we have this being the case, then we say that, oh no, sorry, the square root of x y is greater than y, and that's only going to happen when x is greater than y. But we said that x is greater than or equal to y, right? Didn't we say that? We did say that because we have this over here, right? We have minus x minus y, not minus y over x. So I think it has to be 1/2 then. And it's not the perfect approach that we use, but it works. Okay, let's see what they do over here. Since x and y are non-negative, okay, they wrote them as squares, and then that gets rid of the ugly squaring that we did. So that's a smart thing to do. If a equals b, then both sides reduce to a squared, so the inequality holds. It becomes an equality, in fact, an equation. Otherwise, without loss of generality, we can assume that a is less than b. Then it becomes this, and then oh, okay. So they kind of we did the backwards process of what they did, I think. But obviously theirs is better because it's a purer and more proper approach, I guess you could say. Okay, if they're between 0 and 1, find the maximum value of this. So this is just xy times x minus y. You want to find the maximum value of this. Well, this is like actually not there should be, okay, wait. So the sum of this, x squared y minus xy squared, is greater than or equal to, wait, no, it's a minus though, right? Hmm. Okay, what it would state would be basically the square root, or no need to write that, of x squared y minus xy squared. Something like this, but I don't think it makes sense to use AMGM right away. What we can say instead is that if this is indeed the case, x minus y, the maximum value of x times y is x plus y over 2, and then this is just x minus y, and so this would just be x squared minus y squared over 2. And then the maximum we can have for that is when x is equal to 1 and y is equal to 0. Oh no, but x and y have to be equal to maximize that, right? So I think, but if x and y are equal, then it's going to be 0. Okay, no. This obviously doesn't work. That would just be 0. 1/2 and 1/2 would also give you 0. So it's a little, wait, this is more. For this to be the case, obviously x has to be greater than y, right? Because it's x times y times x minus y. So we know that x is greater than y, and it's not equal to because we need it to be strictly greater than. Find the maximum value of this. Hmm. Wait, I mean, this seems very easy. We just want to maximize x squared y minus xy squared, given that xy belong to 0 to 1. So this shouldn't be hard at all, but yet I think I'm gonna mess it up somehow. What am I doing? It shouldn't be that hard. Find the maximum value of this. Let's get a little hint. It should be some sort of fraction, which makes sense, I guess. The AMGM inequality. Okay, what would this be? X squared y plus xy squared. This would just be, I mean, for this we would just have 1 and 1, right? That would be the best option for us, and that would give us 2. But we don't have that. Well, okay, we probably want to make x as large as possible, right? There's no reason not to do that. So then we just have y times 1 minus y. And then to maximize this, we just want y to equal 1 half, which means it's 1 half times 1 half, which is 1/4. Now it can't really be less than this because, yeah, and this is 1 half minus 1/4, 1/4. Yeah, so 1/4 seems right to me, and it seems like a nice, neat answer as well. But how do we do that? Well, yeah, okay, if you want to maximize this, because you've got an x squared and you've got an, um, yeah, yeah, so, sorry, to maximize this, you want to make xy big, and you want to make x minus y big. And the best way to make both of them big is to just make x equal to 1. Because if x is less than 1, x minus y, sorry, is going to be smaller, and so is xy. This is not hard at all, I think. But what did they do over here? They wrote y times x minus y is less than this. Okay. I think they did that with AMGM. Yeah, x over 2 is less than the square root of x, and then they squared it, and then they found this. And then the maximum value is obviously when x is 1, and that'll be 1/4. Fine. Okay, not too bad. Find the minimum value of this thing now. This is maybe a little bit harder, but should still be fine. How do we do this? X squared plus 1, x squared plus 2, x times x squared plus 2. There don't seem to be any nice, cancellations that we can do here. So there are 4 terms here right now, and that doesn't really seem great for us either because we don't really want that. Okay, well, let's start by maybe simplifying it a little bit if we can do that. Shouldn't be too hard. Like I see the x squared plus 4x, we can probably rewrite that a little bit better. But yeah, I mean, this looks pretty ugly. Little, not too nice. So let's see. Go up here. Okay, let's go. We want to multiply all of these together, and then we just want some cancellations. That's really it. I can already see that, like, if we multiply them together and do AMGM right now, let's just put the basic thing right now, right? maybe we can write this as two different things. Like break it up with some partial fraction decomposition. But that doesn't really seem like it'll be nice either. It'll be probably a little bit messy. So I'm not really interested in trying that out. Okay, 2x plus 4, and then this is x times x squared plus 2. And this is going to be equal to 124, then 4 times the fourth root of, yes, this is where it gets like very, very ugly, right? But it doesn't really seem that bad. Okay, let's see. So we multiply all of these together, and that's not going to look nice at all. So instead of that, maybe we can make the 2 times x plus 2. We can just make that. Will that work? Wait, that doesn't really look good either. Okay, this is pretty ugly again. Like I don't know what's going on here. So this is x plus x over x squared plus 1, sure. Plus x squared plus 4x plus 2 minus 2 over x squared plus 2. So that's just a 1. Right now we've got 1 plus x over x squared plus 1 plus 4x minus 2 over x squared plus 2. But like you see, this is still not really useful for us. 2 times x plus 2 over x times x squared plus 2. Okay, this is pretty ugly still. What can we do here? Find the minimum value of this. If you have any ideas, you can just drop them in the comments, but this seems a little hard. Like it's much harder than I expected. It doesn't really. I mean, maybe we can combine some of the terms together and see if that helps us. But at the same time, that's probably doesn't look like it's going to help us very much at all. It's an AIME inequality, so I'm really only thinking that way, and I can't see anything obvious or even reasonable that could work over here. Oh, minimum value. Okay, that would give us that. Wait, would that give us maximum? Okay, no. Okay, so if you want the minimum value, if we tried AIME, we would get this sum is greater than or equal to something else, and then equate them, and then that'll be your minimum. But instead of this, maybe we can add factors of 1 or something like that to make it a little bit easier for ourselves. But it's just that I don't really see where we could go about doing that, right? Because right now we've got 4 terms. We've got x squared plus 2, x squared plus 2, then an x squared plus 1 somewhere in there, x squared plus 4x. So there are lots of kind of ugly things in here that I don't like the look of. And it's not really clear to me what we can do here to make it nice or to make it neat for us in any way. Well, here's an idea. We can say that yeah, I mean taking the minimums of all of them wouldn't really. Okay, let's see what would happen if we multiply them together. We'd get an x squared on top somewhere, then we'd have an x plus 4 x plus 2, 2, and then lots of other stuff. So it looks really ugly to me. And obviously I don't like that. It seems pretty difficult to work with it. Maybe we can try some partial fraction decomposition on the last term. Right, we know that it's 2 times x plus 2. So it'll be like a over x plus bx plus c over x squared plus 2. And so ax squared plus bx squared equals 0. And then what else do we know? We know that 2a, well, yeah, that's it. 2a equals 2. Because there's, right? Yeah. And then cx is equal to 2 as well. Right? Because this is 2x plus 4. So sorry, 2a would equal 4. Cx would equal 2. And what does this give us? This gives us, well, 2 over x plus negative 2x plus 2. Does that seem right? Yeah, that seems fine. Because a is equal to negative b. I don't know if I expanded correctly, but it seems about right. It's fine. So cx is equal to 2. So c is equal to 2. Yeah, okay, this looks fine. And now we haven't helped ourselves much, except now we've got 5 terms, so we'll have to take the 5th root when we do AMGM, which is probably not really appealing. Yeah, it's pretty bad. But okay, this is just an irritating question. Find the minimum value. Oh, okay, we could worst case just use calculus and take the derivative, but that's also really bad. That's not going to work well at all. Find the minimum value. We can maybe say something about the denominators, right? Or maybe you can take the minimum value for each of the terms individually, but none of that really makes. Yeah, like if you just find the minimums of each term of each of the things, like obviously the minimum of x is just um x is greater than 0 to be like 0.001, but that wouldn't really be the case for the other things. It would probably be something else. So okay, wait, let's do this. Let's do AMGM on just the last 2 terms and see what we can say about that. So this is now x plus x over x squared plus 1 plus x times x plus 4 over x squared plus 2 plus 2 times x plus 2 x times x squared plus 2. This is greater than or equal to x plus x over x squared plus 1. This here would become what? It will become x times x plus 4 times 2 times x plus 2 over x squared plus 2 squared, and there's another x over here, but this cancels with this, and nicer. Right now, what else would we have? We would have that divided by 2. So this would be greater than or equal to this plus 2 times the square root of 2 times x plus 4x plus 2 over x squared plus 2. I think that's what we would get. That seems about right to me. Now, what else can we do? Where else can we get some nice cancellations going? x plus 4 times x plus 2, that's just x plus 3 whole squared minus 1. Hey, that's a difference of squares. It's x plus 3 minus 1, x plus 3 plus 1. So we can do that. So this is equal to x plus x over x squared plus. We can probably do AMGM on this as well, actually. And actually, that shouldn't be too hard at all. Okay, we'll try that. Plus, and what does this become? This will become 2 times the square root of 2 times x plus 3 squared minus 1 over x squared plus 2. Okay. Now, what do we get over here? Now it's greater than equal to, still greater than equal to. We can once again do the same thing and we'll get 2 times the square root of x squared over x squared plus 1. Two times the square root of 2 times x plus 3 squared minus 1. Yeah, I mean, this still doesn't look nice at all. It looks pretty ugly to me. Is there anything here that's, smart that we can do? I don't really think so. Um, yeah, okay, this seems pretty stupid to me still. Should we have done the AMGM with something else? Maybe that's what we should have done. Okay, let's. We can maybe consider bringing in some of the terms, but I think it's easier the way it is right now, written right now. And all right, let's just skip this, multiply and get rid of fractions. I would, but it seems too difficult to multiply by so many things, right? Actually, you don't know. What do we have to do? We don't. Yeah, yeah, maybe that's the case. There's not that much that we have to do. All right, let's try that. So we can multiply the first one. We can multiply this by x. So it's x squared times x plus 4 over x squared plus 2 times x plus 2 times x plus 2 over x times x squared plus 2. And this will become x times x squared plus 2 over x times x squared plus 2. And now we want to multiply these all by x squared plus 1 over x squared plus 1. But before that, we can just add these all up and see what we get. So that will give us x cubed plus 2x plus x cubed plus 4x plus 2x plus 4. Right? And what does this give us? This is 2x cubed plus 8x plus 4. Right? I think that's it. Yeah, that seems about right. And now, what is this divided by? This is divided by the x times x squared plus 2. So we just want to multiply this by x squared plus 1 over x squared plus 1. And so what is this now? This is going to be x squared plus 1 times this. And then this is x times fine. So, and then there's a plus in here. So this is what we would get if we expanded it. But it doesn't, again, I mean, it seems a little ugly. Um, yeah, I don't really see any patterns here either unless we can, because we'll have an 2x to the fifth, then we'll have an x to the fourth, and then we'll have 2x cubed plus 8x cubed, so that's 10x cubed. So it gets pretty ugly. So we'll hold off on this for now then, and just like we did on that other question. And let's go on to the next topic, the Cauchy-Schwarz inequality. Okay, so we can write this like sine to the fourth x plus 3 halves cosine to the fourth x. We want to find maximum or minimum value. And so this is sine squared x squared plus cosine squared x squared, right? Oh wait, no, one sec. Minimum, so wait. If you can just do it like this, right? You can do so like this times something else is greater than or equal to sine squared x plus root 6 over 2, I think, cosine squared x squared. And yeah, and so this is all we really have to do to find the minimum value. We know that this is 1 plus root 6 minus root 2 over 2 cosine squared x. Well, I mean, actually, I don't think we even have to do the, okay, we'll do it. Cosine squared x, and then since it's already cosine squared x, right, you can't really minimize that. You can't, sorry, you can't make it negative. So the minimum value of that will just be 0. And so it should just be 1, right? But that doesn't really seem right. Let's see. It should be some sort of fraction. Find the minimum value of this. Sine to the fourth x plus 3 halves cosine to the fourth x. So we want this on the side of the Cauchy-Schwarz thing. Like we want it kind of like this. But maybe also write it as, oh wait, no, sorry. Then this will be 1/2 then, right? Because there's a 2 over here as well. So 2 times, okay, let's check this once and see. What is a, yeah, wait, no, this doesn't seem right, but let's see. There'll have to be a value for which this is true as well. And that value shouldn't be too difficult to find. Yeah. Okay, so if this is the case, we can't pick our own random value of x because that won't really make sense in this context, right? It won't really work. So instead, maybe we can say, okay, well, let's just start with a slightly cleaner approach maybe. And just write sine squared x plus cosine squared x, which is 1. Square that and we'll get sine to the fourth x cosine to the fourth x plus 2 sine squared x cosine squared x. And then we can write that in terms of cosine to the fourth x, right? So that, let's just actually try that before doing any of this. And I'm doing this because it'll probably be a little, actually no, it doesn't really seem like it'll be nicer, but this is equal to 1, right? And so, that's sine to the fourth x plus cosine to the fourth x. Yes, it'll be 1 minus 2 sine squared x cosine squared x plus 1 half cosine to the fourth x, which is 1 minus 2 times 1 minus cosine squared x cosine squared x plus 1 half cosine to the fourth x. And now we can do a little bit more over here. We can write this as 1 minus 2 plus 2, sorry, 1 minus 2 cosine squared x plus 5 halves cosine to the fourth x. And now take the find the maximum value of this. Find the maximum or minimum? Find the minimum value of this. And that's the same thing as, right, it's upwards, so you just say, what would it be? When would it be? It would be at, wait, can we even say that? If we let, yeah, sure, okay, y squared minus 2y plus 1. So it would be at 2y, or no, I mean just 2 over 5 fourths, which is 8 over 5, which isn't really in the domain. So, okay, yeah, let's just go back to using an inequality like we're supposed to. So it's sine to the fourth plus 3 halves cosine to the fourth x. You want to find its minimum value. If we could just make, like, I guess we can write it like this as well. And then there's a 1 half, so that'll be root 2 over 2 cosine squared x squared. And then this times 1 plus 1 plus 1 squared 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 is greater than or equal, what? It's greater than or equal to sine squared x plus cosine squared x plus root 2 over 2 cosine squared x squared, which is 1 plus root 2 over 2 cosine squared. Yeah, I mean, this doesn't really help us here either. And then you would divide this by 3. But to be equal, you would need them all to be, right, for equality, you need these all to be equal to each other, because you need sine squared x over 1 to equal cosine squared x over 1, root 2 over 2 cosine squared x over 1, and that'll never happen, because that would need sine squared x and cosine squared x to both be 1 half, but then the root 2 over 2 won't work. So that doesn't really work for us either. Find the minimum value of this. What is our original thing over here? It was slightly different. Yeah, it was like this. Sine squared x plus root 3 over root 2 cosine squared x is equal to this. So root 6 over 2. Yeah, okay. Yeah, I mean, this seemed a little promising, but okay, why don't we say that for this to be true, we need these two to be equal. And if this is the case, then we can just find the value of cosine squared x, right? This is 1 minus cosine squared x equals root 3 over root 2 cosine squared x. So put that up over here. You get root 3 plus root 2 over root 2 cosine squared x equals 1. And now to solve this, we just have root 2 over root 3 plus root 2 which is root 2 times root 3 minus root 2, which would be a very small number, right? It would be about 0.4 or 0.5 for cosine squared x. And now we can put in into this equation up here. And we get 1 plus root 6 minus root 2 over 2 times root 2 times root 3 minus root 2, which is very ugly to look at, but there are there are going to be some cancellations here, right? This will become 2 times root 3 minus 2 over 2 times root 3 minus root 2, which is root 3 minus 1 times root 3 minus root 2, and this would be equal to just 3 plus root 2 minus root 3 minus root 6. And if you do the math on that, that'll be pretty small, and then you add the 1, so you get 4 plus root 2 minus root 3 minus root 6, which is obviously wrong because that's nowhere near the format that they were asking for, which was supposed to be a fraction. Okay, wait, this is just oh yeah, okay, let's take the derivative. So sine to the fourth x would give us sine x, no, sine cubed x cosine x, and then this would be minus 6 cosine cubed x sine x equals 0, from which we can cancel out a sine x cosine x, actually a 2 sine x cosine x, or sine 2x, and then we get sine squared x minus 3 cosine squared x equals 0, and so we get sine squared x over cosine squared x equals 3 halves, which means tan x equals root 6 over 2. And if this is the case, then well, we don't really need that, because we know that, wait, no, sorry, what does this give us? This just gives us, this doesn't do anything. This just tells us sine squared x is equal to 3 halves cosine squared x. We already said that here in Cauchy-Schwarz. We already had this. So I don't know if that really helps. We might have to consider the edge cases when, like, see, if we have if we make cosine x 0 and sine x 1, then we'll have 1, but that's probably not the minimum, right? There should be a minimum less than that. And so for that, we want to make, oh no, sorry, that was root 3 over root 2 cosine squared x. This is different. This is a little nicer. Okay, let's try it then. So when you add it, you get 1 equals 5 halves cosine squared x, which means cosine squared x equals 2/5. And if cosine squared x is 2/5, then root 21 over 5 is sine squared x. If you square these, you'll end up getting like 4 over 25, and no, sorry, sine squared x will just be 3/5. because they add up to 1. And then when you now square this stuff, you'll get now when you square this, you'll get 9 over 25 plus 3 halves times 4 over 25, which is 18 over 50 plus 12 over 50, which is 30 over 50, or 3/5. Okay, let's see if this is correct. 3/5, 0.6, and this happens, yeah, I mean, it might work. Let's try it. Okay. Yeah, okay. It was so easy with Cauchy-Schwarz. I don't know why I didn't do this. Wait, what did I mess up then? I think I did something similar. Okay, I picked the wrong things. I put 1 and 1 instead of 1 and 2/3. And because I was trying to write it as sine squared x and √3 over √2. But yeah, that was obviously a very ugly choice. Okay, let's try one more and try to redeem ourselves. We know that a plus b plus c plus d is 1. Find the minimum value of this. So the minimum value will be, well, I mean, yeah, we can write this as, it'll be 1/4. I'm pretty sure it'll be 1/4. And okay, I don't want to get like that, but a squared b squared plus c squared plus d squared. And then we can multiply this by 1 plus 1 plus 1 plus 1 is greater than or equal to a plus b plus c plus d whole squared. And then we know that this is 1, so it's just 1/4. Right? Okay, yeah. By Cauchy-Schwarz. And you could have done this with the other thing as well. Simplify this. Okay. Well, this is, oh, I'm pretty sure because they're conjugates, the final results are also going to be complex conjugates. And so, well, okay, what is the magnitude of this? Cauchy-Schwarz is this over here. It says that a sub n squared plus b sub n squared plus, or no, I mean, it's easier to write it like this. Okay, I'll do it like this. A sub 1 squared plus a sub 2 squared plus a sub n squared times b1 squared plus b2 squared dot plus b sub n squared is greater than or equal to a1 b1 plus all the way until a n bn whole square. Right, so if you put it in words, it's a little hard to understand, but it's essentially the product of sum of squares is greater than or equal to the square of the sum of the products. These are the you're summing them up and taking the product of that. And over here, instead of doing that, you're taking the square of the sum, right, of each of these products. That's what the theorem is, and that's what we used over here. And oftentimes b1, b2 is constants that make your work a little convenient. Okay, we'll be doing more questions, including that, after this little review problem break, so we can work on that a little more if you want. So yeah, 3 plus I root 3 over 2. This has a magnitude of what? It's going to be, well, what's the numerator's magnitude? It's just 9 plus 3, which is 12. 12 divided by 2, 4. So 12 is 2 root 3, so it's just going to be root 3. So it is root 3 times root 3 over 2 plus I over 2. And we want to raise this to the 8th. So this is raise to the 8th. That's root 3 times CIS of what? What is the angle over there? It's got an x component of this is 30 degrees then, right? I think that's just 30 degrees because the real component is root 3 over 2, the imaginary component is 1/2. That seems about right. And we want to raise this to the 8th power. So that's just going to be 64. No, sorry, not 64. It's going to be 3 to the 4th, so 81 times this, which is also just negative 120 degrees, right? Plus 81 times this of, it'll be, so I think it's, let's see, 3 minus root 3 over 2, that would just be negative 30 degrees. So this is now negative 240 degrees. This is using De Moivre's formula or De Moivre's theorem. And so we can take out an 81. And now what is this going to be? Well, we can draw it out a little bit. It'll be negative 120. So that'll be right around here. This is 240 degrees. And well, yeah, so there'll be this and then there'll be this. Okay, this is negative, this is 240 degrees. This is negative 240 degrees. So we add them up. Vertical coordinates are going to cancel out. So we just want 2 times, so negative 2 times 81 times that component is. And because this is 120 degrees, this is 60 degrees. And so this part over here is going to be 1/2. I think, yeah, that's 1/2. So 1/2, so this is negative 81. All right, great, done. Let A and B be real numbers. Find the maximum value of this in terms of, okay, this is perfect. This will just be the square root of a squared plus b squared using Cauchy-Schwarz, because yeah, because you can write it like this: a squared plus b squared times cosine squared. But you should also probably just know from geometry, like when you have to combine something of the form a cosine theta plus b sine theta, you can write it as just one sinusoidal function. But if you show it, you can write it like this. So x. Right, and so a squared, this is just 1. So it's a squared plus b squared. Square root of that is less than or equal to a cosine x plus b sine x. And yeah, so this will happen at the max value. And so that's the amplitude. And yeah, I think we're done. Oh, 4 out of 13. I remember I used to try these earlier on, and I was very bad with it because I'd never learned the formula. I just thought I'd try to solve them in another way. But it's good now I know what they are. So find the minimum value of this. So there are probably a few different ways we can try this out. Huh. Well, okay, let's see. Which kinds of questions, Subhakanta? Also, is your first name Subhakanta, or something else? Because I don't want to call you by the wrong name if it's not your actual name. Anyway, okay. A1, A2, A3, so the sum is until 11. Oh, sorry, A12 is equal to 1. And so if you want to find the minimum value of this, you'd probably like to have this on. I see, okay, yeah. Sorry, yeah, minimum value of this, we would probably you'd want this on the left hand side, but it won't really be nice. So what can we do here? Okay, this might be a little ugly, but if we write it out, wait. Huh. Find the minimum value of this thing here. It'll probably not be too. What would happen if we took something like 1/12th, 1/12th, 1/12th? We'd get a pretty big number. But if we did something like 1/13th and one, okay, wait. So I think it should just be like 144, but I'm not fully sure. So I'm going to be a little more careful than that. We want to use this and then use the squares. So I'd like to get a1 plus a2 plus that, and then get that squared. But okay, wait. Oh, okay. Never mind. 1 over a1 plus 1 over a2, blah blah blah, times a1 plus a2 plus blah 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 until a2. This is the same thing as 1 over a1, so the square root of that, plus 1 over, okay, it's pretty ugly. Same thing, I know. And then you square each of these. But write that, all we need to write it is like this. And then we know that 1 over the square root of a1 times the square root of a1 is also 1. So this is going to be greater than or equal to 1 squared. Because it's, well, no, not 1 squared. 1 plus 1 plus 1 squared. And this is 12 squared. This is 1. And so it's just going to be greater than 144. But you could also just guess that if you just say a1, a2, a12 are all 1/12th. Because if you take, like, because in math, it's not going to be some really random combination. There'll be some symmetry or some, yeah, some sort of symmetry. So that's how I guessed it. And then I did the actual thing as well. Similar thing over here, I believe. Find the minimum value of this. So, huh. Um, okay, to find the minimum value of this. So we'll put this on one of the sides, and then I'm pretty sure it's just 1 plus 2 plus 3 plus 4 plus 5 plus 6 on one side, right? Because, or okay, like this. We want to find the minimum value of this. Well, okay, wait. If you want to find the minimum value of this. How would you get something like this? Like, it's not too easy to get that. Unless you like, oh, okay, it's the same logic then. 1 over a plus 4 over b plus 9 over c plus, and then we go until 36 over f. And then all we have to do is multiply this by a plus b plus c. So, and the reason this works is because again we can take the square root, but now we have to be a little bit careful, I think, because well, no, we're fine. And this is going to be greater than or equal to what? Well, it's going to be this times this, but the square root of that. So that's 1. B times 4 over b, but the square root of that, and so on. And so that's going to be 1 plus 2 plus that until 6, and then you square that. So we know that this is equal to 7, I think. So it'll just be this divided by 7. And that's the minimum value. Right now, to actually solve this, so yeah, I mean, that's not hard. Um, because it is squared, it's just n times n plus 1 times 2n plus 1 over 6, and then we multiply by 7, and then just plug in 6 and 7 and 13, and that's our answer. Ooh, okay. I see. Maybe I messed it up here. Is it n plus 1, 2n plus 1 over 6, 6, 7, 13? Okay, well, maybe I messed something up. Let's just check and see if that's the case. A, B, C, D, E, F, yeah. No, I don't think it's 13. I think I think I messed something up here. Let me check. So this would be 25 plus another 25, that's 50. That would become 91. Oh, it is right. 91 over 7 is 13. So how is that wrong then? Okay, wait, this maybe I messed something up the first time. No, it seems all right to me. But what did I do wrong here then? Squared. Did I square this? Yes, oh, no, sorry, I'm an idiot. 1 second. It's not, okay, yeah, obviously that's wrong. I did 1 plus 4 plus 9 plus 36. Should not be that. It should just be 1 plus 2 plus 3 under 6, which is 7 times 321 squared over 7. Is that correct? 10, 15, 21, 21 squared. Oops. And so that'll just, yeah, I wrote the same thing. Great. So that'll be 3 times 21, which is 63. I think that's it. But let me just double check now. 21 times 21 over 7, 21 times 363. Yeah, that should be fine. Correct. All right, great. Um, this one should be like, it's like 13 or 169, I think. Because it'll be, I think it'll be 13. Let's try. So we have x squared plus y squared plus z squared times um 3 squared plus 4 squared plus 12 squared is greater than or equal to, yeah, is greater than or equal to 3x plus 4y plus 12z squared. And so this is 5 squared, this is 12 squared, so this is 13 squared. Pythagorean triple, two Pythagorean triples actually together. And then this we know is 1, that's just given to us. So this is greater than or equal to the desired quantity squared, and so it'll just be 13. Pretty quick. Like some of these, I think when you just recognize the numbers and you know it's an integer, you can guess. All right, one more over here now. Find AB plus AC plus BC. That's just one of the symmetric sums, so I think that'll be 11 over 3 from Vieta's formulas, yeah. What is the difference between the maximum and minimum possible values of C? All right, so so I guess we can try to bound it in two different ways. This one's a little, maybe a little more challenging. A plus B plus C is, where can I write on this? Let me find some space here. So we know that A plus B plus C Oh, let me more. A plus B plus C is equal to 2, and A squared plus B squared plus C squared is equal to 12. And so that A squared plus B squared plus C squared times 1 plus 1 is greater than or equal to A plus B plus C whole squared. Wait, what? Yeah, okay, sure. That seems right. Seems correct. Oh, no, no, no. What is the difference between the maximum and minimum possible values of C? Okay. How would we do that then? This doesn't even A plus B plus C, that's 2, so this would be 4. This would be 3 times 12, 36. That's true, but if you want maximum and minimum possible values of C, okay, so it shouldn't be too difficult to figure that out, but I don't know what we do. If we square A plus B plus C, we get A squared plus B squared plus C squared plus 2 times AB plus BC plus AC, A plus B plus C squared whole squared, which means 12 plus 2 times AB plus BC plus AC is equal to 4. And so AB plus BC plus AC equals -4. How does this help us? Well, we know that this is just A squared plus B squared plus C squared. No, 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 no. I don't think that's that helpful. Obviously, we know one of them has to be negative, right? And we can solve for C now in terms of that. So C times A plus B equals -4 minus AB. C equals negative 4 plus AB over A plus B. Okay, that should be that's correct. And okay, well, what is A plus B plus C? That's going to be greater than A plus B plus C over 3 is greater than ABC, the cube root of that. So 3 times the cube root of ABC, which means 2 is greater than 3 times the cube root of ABC. So the max cube root is no. Okay, that's not too helpful either. Minimum, maximum and minimum possible values of C. Maybe we can subtract the first equation from the second, which would give us, sorry, that would give us A times A minus 1. And this would be equal to 10. But okay, I'm not too sure. This is a little messy, I think. It's not that obvious at least. Hmm. How can we use the Cauchy-Schwarz inequality for this? We want the maximum value of C or the minimum value of C. Uh, so okay, to make this true, we need like 2, -2, and +2. And so the minimum value of c would be -2, maximum value of c would be 2, but it's a fraction. So that's also has nothing to do with the inequality, right? You can just guess that, I think. A squared plus b squared. Let's do the same thing with a plus b and a squared plus b squared, which is pretty easy to do. A squared plus b squared times 2 is greater than or equal to a plus b squared, right? That seems about right to me. So we know that a squared plus b squared is greater than or equal to 2ab. But that doesn't really help us with much, does it? Ugh. Yeah, I don't think that helps us too much. What does this do for us? 2ab is okay, well, let's leave it like this then for now. See what we can do with this. Okay, no, what would the minimum value of c be? Like logically, what would it have to be? And what would the maximum value of c have to be? I don't know what we can do here, but it's symmetric around about all of them, first of all. So if we let, so okay, we'll say c is less than b is less than a. So a is, okay, you know, no, let's skip this for now. Let's just do one, or we've barely done any questions, right? So it's pretty bad. So let's just find partial fractions. Maybe there's something useful here. Okay, I mean, this is pretty easy. X plus y should just be equal to 5. Okay, yeah, this sounds not as easy, but a plus b plus c plus e. So if we just take -1 in for x, yeah, if we just plug in x equals -1, we'll get exactly what we want. So, and the denominator there will also be 1, so it's just 5 times 1 minus 8 times -1 plus 2 times 1 plus 4 times -1 plus 7. So let's simplify this. That's 5 plus 8, 13 plus 2, 15 plus 7, 15 plus 7, 22, 22 minus 4, 18. Yeah, okay, and then you just divide it by -1. I mean, plug in -1. Find a plus b. Oh God, okay. Well, these are the roots, right? And we know that, once again, um, oh no, wait. Okay, if you multiply these together, you're going to get a times -b, uh, sorry, a times this whole thing plus b times this whole thing. And so, well, let's just take x equals 0, and then we get 1 over c is equal to this. Okay, that doesn't really help us. If we could make the denominator like 1 or something, that would be great, but we can't do that. You know what, we can make the denominator -b over 2a. What will that do for us? That won't do much either. Okay, oh God. A plus b has to be 0, right? Because it's ax and then bx and that equals 0, so it's just 0. They have to be negatives of each other. This is, okay, this one's easy. Should be not too bad. It's like 1/2 times 1 over n minus 1 over n plus 2. And when this goes on forever, you're going to have 1 over 1. So it's Is it? It's 1 over n minus 1 over n plus 2 is 2 over n times n plus 2. So actually, let's just write it. I think okay, I'll try the answer on my own once, and then I'll see if it's correct. My answer right now is 3/4, but I don't know. Let's see. Is it 1 to infinity? Yeah, and 1 over times n plus 2. So this is 1/2 times the sum from n equals 1 to infinity of 1 over n minus 1 over n plus 2. And then this is just telescoping. So it's 1 minus 1/3 plus 1/2 minus 1/4 plus 1/3 minus 1/5. This cancels with this. Everything else will cancel, but you'll be left with 1 and 1/2 here. And then you multiply this by 1/2. So this is 3/2 times 1/2, which is 3/4. Yeah, that's correct. Let's try this next one. Holds for all your numbers other than -5 and 3, which makes sense. Yeah, of course. Let's try 4. Let's just plug in 4 and see what happens. Oh, no. What is A? Well, okay, that's not good. Okay, well, I think we can say did you say 0 for this question? I don't see the timestamp, so I'm not really too sure. But let's see. What is A over here? Holds all your numbers x other than -5 and 3. Can we factor the left? Yeah, obviously you can factor it into this thing here. X minus 3. Yeah, okay, fine. So it's not too interesting, but um, if we plug in 4, we'll get something about A, B, and C. Okay, you know what, let's just take this to the, we can't do this in our head. We need to find A. Find A. And this is going to be the last question because it's 4:55 now and I have to do some other work as well. And it's been a long time. But okay, so this would be what? Well, I mean, no, we don't even have to do anything. We can like just say, oh, so it's A times x minus 3 squared plus B times x plus 5 x minus 3 plus C times x plus 5 x minus 3. Right? I think that's correct. No, sorry. It's just C times x plus 5. We don't need that other thing there. This is going to be equal to 1, which means that, well, A times x squared minus 6x plus 9 plus B times x squared plus x minus 15 plus cx plus 5c is equal to 1. Now we know that ax squared plus bx squared is 0. So a equals -b. So we can just plug that in over here now. And now we can just solve for x with c. Well, first of all, we know that 9a is times -a, so that's plus 15a plus 5c equals 1 constants. And now we know that -6a minus 2a plus c is equal to 0. And so we just solve this now, which shouldn't be bad. This is, just multiply this by 5 and put it in there. So this is -8a plus c equals 0. And here we've got 24a plus 5c equals 1. We'll multiply this by 3 and add it. And in doing so, we find that 8c equals 1, which means that c equals 8, so that 3 over 8 equals 24a, which means a equals 1 over 64. Okay, now let's see, this should be right, hopefully. Oh, then when you substitute -5. Okay. Yeah, I mean that makes sense. You can still plug in the values and just make the other the ones that don't have that get multiplied by -5, make them go to 0. That's obviously the probably the smart way to do it, but we still got it done. We'll do one last one, I think. There are values a and b for this to be true. I mean, all right, we can just find a first, -6 and then 1. So a equals 1, and then what is b? B is going to equal 3 plus 1, 4, so that should be 5. Okay, we're just one away now, come on. Let this be the case. Find f -1 of x. So that's x plus 2, wait. X plus 2 squared plus 1 is equal to y. So now we switch this into this. And so that's x minus 1. It's the square root of this. And then it's -2 plus that. Right, find this and then, oh, oops, that should go away. -2 plus that square root. And it's defined for x is less than -2. So it shouldn't be x minus 1, it should be x minus 2 because that's what we need to be back by 7 o'clock. Yes, we plan it that way. Half an hour. Yeah, okay. All right, yeah, let's check this once. No, sorry, this should be 1, right? Or what? Okay, no. I think I did it right. It's like this. And so this is what we initially had, right? X squared plus blah, blah, blah equals y. And now we switch it. And we want x to be less than or equal to -2. Meaning what? I mean, we just need to figure out if it's plus or minus, I guess. All right, let's see. So no, this should be -1. And will x be, oh no, if x is less than or equal to -2, then this has to be a minus, I think. And I think that's it. Oh, wait. So do we just want this then? It's the square root, right? Yeah, okay. All right, perfect. And we went a little bit over, but we finished inverse functions. Oh, no, we didn't finish. Okay, wait, great. We finished. So, okay, we just finished inverse functions. And right before this, we got there because we finished this other thing. The, whatever it is called. The one before that we were just doing, which was partial fractions. We finished partial fractions and that. So it's not bad. We didn't do too much today. Let's see the profile or whatever. Yeah, I don't know what these numbers mean, but I mean, they look good to me. You've done 1,028 problems. And let's go up here to report to see. 1, 2, okay, how many questions did we do today? 716, okay. Last thing I did was like 5 months ago. No, 7 months ago. So it's been a really, really long time since I did Alcumus. But okay, we did 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26. We did 26 questions. Not great, but and how long was the stream? Let me check. Let me check that. Yeah, it's been 2.5 hours. So 2.5 hours, that's 150 minutes for 26 questions. So I don't like that ratio. I can't really figure out what it is right now. But that's about 150. Yeah, okay, that's like 6 minutes per question. Some of them were hard, some of them were not hard. But we ended up doing all of them. So, and I don't think we got any of them wrong either. So yeah, that was pretty good then. Thanks so much for watching. And yeah, I think that's it. No one else is really waiting now. So I'm going to end the stream soon. Thanks for attending. Thanks.